When you're insulin resistant, that is, you've got metabolic syndrome, pretty much every chemical in the body is not quite right. Some are up, some are down, few are actually at physiologically normal levels. Traditionally, the focus is on the big guns, sugar, insulin, and cholesterol. In this series, we take a look at some of the other players, who they are, what they're up to, and how they're part of the state of insulin resistance. In this video, we feature hepcidin. Now, hepcidin is up, and this impacts iron metabolism, typically manifesting as an apparent iron deficiency. So, who is hepcidin? Well, he is a mining magnet, controlling the acquisition, storage, and utilization of iron in the body. He controls every cell's access to iron, either directly or indirectly. And every cell includes all the cells that make up the human body, as well as any microbial cells hoping to take up residence. In the body, iron is a precious commodity. It runs a lot of chemistry. The chemistry that springs to mind for most people is oxygen delivery. Iron is the molecule at the center of hemoglobin, which is the protein responsible for carrying and delivering oxygen. And oxygen is a requirement for life. But iron is also involved in respiration, in DNA synthesis, detoxification, the regulation of gene expression, as well as growth and development. Overt shortages of iron typically show up as anemia. Now, anemia is not always about iron, but 9 times out of 10 it is. Hepcidin is a shrewd businessman. When you're running a mining operation, it's not the same as running a bank. You've got to be tough and hands-on. Hepcidin uses brute force to run his mining operation. His modus operandi is to control the one and only iron exporter pump, very important. Hepcidin renders this pump inoperable, ouch, in one foul swoop. Hepcidin controls the entire iron supply chain. Very important pumps are located on the enterocytes, which are the cells that line the gut, and these cells are responsible for iron uptake, as well as the macrophages, which are the workhorses of the immune system and responsible for iron distribution. Disabling ferriportin in the enterocytes stops mining operations. It all starts with dietary iron, which may be bountiful or rather deficient. Either way, the enterocytes grab as many iron molecules as they can when they pass their way. The iron is gathered and then moved inside for storage. From here, it is moved into the body by the ferriportin pump, assuming the pump is operational. If not, well, the iron is stored until it can be moved out of the enterocyte, or the enterocyte falls into the abyss, whichever comes first. You see, enterocytes' days are numbered. They're born in the villi crypts and then move up to the top of the villi where they get sloughed off. When this happens, they take the iron supply with them. So iron uptake takes a knock. Disabling ferriportin in macrophages curtails iron distribution. The macrophages come in different shapes. The ones stationed in the spleen are professional iron guzzlers. The spleen is the place where old, damaged red blood cells are euthanized. The macrophages in the red pulp gather all the iron the red blood cell is carrying. And for the record, it's a lot. An average red blood cell has 280 million molecules of hemoglobin. And one hemoglobin has 4 heme groups, and there is an iron molecule buried in the center of each heme group. So we're talking about over 1 billion iron atoms per red blood cell, and millions of red blood cells are being euthanized per minute. The macrophages gather it all up and make it available for recycling, assuming the ferriportin pump is functioning. When it's not, well, they hold on to it. This serves to keep iron levels in check. Now you might be thinking, why would hepcidin deliberately keep iron levels low? Well, it's all about supply and demand. Iron is a good thing, but too much of a good thing is a bad thing. This is particularly true when there's a possibility of a microbial invasion. To go forth and multiply, bacteria need iron. They will beg, borrow, or steal it. Hepcidin knows this, so he deliberately keeps iron out of their reach, which is why hepcidin levels are typically high during an infection or if there is inflammation. But it is a fine balance. Hepcidin practices just-in-time management. He makes sure the iron is made available only when it is needed, because hepcidin understands life exists on the interface of too much and too little iron. When you're insulin resistant, hepcidin levels are up. This is not an accident. It's strategic. But over time, body iron stores increase. Unfortunately, the stored iron is not accessible. Now, trying to fix the problem by consuming extra iron is not the solution. In fact, in the long run, it can lead to new problems. You've got to lower the hepcidin. Now, if you understand the biology, this turns out to be easier than you might think. Here are the references I've used to tell the hepcidin story. Hepcidin is just one of hundreds of chemicals in the body that are amiss when you're suffering from metabolic syndrome. You can learn about some of these other players in the ups and downs of insulin resistance series. Thanks for watching, and I'll see you next time.